for the next team, Segway Militia, and you know, they did something really cool. They put an attention to detail to the cinematics. As you can see, like as games became more of a valid type of entertainment, you can see we've been stealing things from the movie scene, right? So like in The Matrix, they had all those camera spins and everything went into slow-mo. You can see even in the last game, slow motion's cool, right? So we've been stealing things from that. This next team has taken a lot of that stuff and put a focus on it, so they did a really good job with that. I'd like to introduce Segway Militia.
Well, how's everyone doing today? Yeah. Well, now for something completely different. We are Segway Militia. I'm Matthew Skillings. This is Adam Schlesinger, Brandon Hilton, Christopher Venezia, and Adam Schellenbarg. I get their names confused. It's really easy. And we're here to talk to you today about our game, Rider. Rider is a hoverboard racing game where you race against the clock, and the goal is to get the highest score possible. And it takes place in San Francisco of the future, and it's the year 2400, and San Francisco has become, the prisons have become overpopulated, and in an attempt to change this, the scientists of the era have decided to genetically engineer inmates and sort of reduce their aggressiveness. And it worked, and they released them to the general populace, but there's an unforeseen consequence where the genetic mutation runs wild, and the inmates eventually turn into giant hulked out monsters. And because of this, the military has no chance to save the city, and they've decided to just destroy the entire city in one giant nuclear explosion. And this presents a problem for our main character, Ray. She is a hoverboard scavenger in the city of San Francisco, and she hears about the bomb being dropped and must escape before it lands, and she is destroyed in a giant cloud of vapor. And she will accomplish this through a series of QuickTime events and dodging. And a QuickTime event is, in our game, the character Ray will go and hit a jump, and a button will pop on the screen, and you will have to press the correct input, and she will perform a trick, which will then give you a boost and present a cinematic camera angle, and then she will continue along her path. And the goal is to get as many of these right as possible to increase both your points and your boost. And to talk to you a little bit more about how we got the tricks into the game and how we got them working, I'm going to bring up Brandon Hilton.
Thank you, Matt. Excuse me. Thank you, Matt. My name is Brandon Hilton. I'm the project lead at Segway Militia. So behind me, you can see some of the things that I worked. Oh, excuse me. Now behind me, you can see some of the things I worked on. But today, I'm going to talk to you about skinned animations. To give you an understanding of what skinned animations are, I'd like to do a comparison between articulated and skinned. Articulated is when you're trying to show a movement on an object or character that has segments that are joined together, such as our robot friend here. For skinned animations, you used for characters that have skin or have fluid movement, such as humanoid characters, or for us, our character. So how do you do this? How do you do skinned animation? Well, the first thing to do is start rendering bones. These come out in the final rendering version, but this is a quick and easy step. From here, you're going to go to keyframe switching. Keyframes, you can think of those as if you were to take a movie, and you were to take every 5 frames and you'd cut 4 frames out. What you're left behind, those frames left, are keyframes. They give you enough information to know what's going on, but you don't really get fluid movement. This cuts down on data when we're storing them inside the game. After getting the keyframe switching, you're going to switch to a hierarchy, which is a more complex structure, or in our case, our character. Next, we're going to go to rendering mesh. This is basically putting the skin on the character. And as you can see here, the skin is hard attached to the bones, so everything it'll snap around still because we have the keyframe switching manually. We fixed that by finally doing interpolation. This is filling in those 4 frames that we took out earlier to save down on data storage, but now we put that fluid movement back in and you really get a nice smooth looking animation. So why did we do skinned animation? We did this because we have a human character, and like I said before, it looks really good for characters with skin. We also have a lot of complex tricks in the games, our trick system, and we wanted to make sure that those looked really good and really played with the cinematic feel, which is the next part where we have the camera going in very close a lot of times. So because of that, we wanted to make sure it was never, sorry. The cinematic feel, we just wanted to make sure that the character looked good at all times. And now to talk about how we did the tricks inside these scripts and our QuickTime system, I'm going to bring Matt up.
Hello again. I'm still Matthew Skillings. I was the asset and QA lead at Segway Militia. And behind me are some of the things I worked on, but I'm going to talk to you today about the scripting system using Lua. And first of all, what is Lua and what are scripts? Lua is a lightweight programming language that integrated very well with our main core technology. And a script is a set sequence of events. And in our game, it is used to, when the player hits a jump, the scripting system takes over and controls what button is displayed, what animation is displayed if there's a correct button press, how fast the player moves, where the camera goes, and any of these variables is all controlled through a script. And why we use Lua is because we were interested in learning another programming language. It's widely used in the game industry, and because it's based in the same language of our core game technology, it was very easy to integrate into the system. Using Lua, to get it to work correctly, I had to do multiple scourings of the internet to try to find any idea how to get it working within our system. I had to purchase the 3 books you see pictures of up there and research the whole time I was spent researching how to get Lua to work. And once we found a solution, we put it in our game and it was ready to go from the moment we had it. And Lua in our game, as I said before, controls all aspects of quick times, camera movement, rotation, anything happening within a quick time event is controlled through the scripting system. And it also is tightly integrated with the Bezier curve system, but also it is exceptionally fast to make changes to. If we wanted to make a change to a script using not using Lua just in our game, it would take roughly 2 minutes to make the change, compile the game, and get it to test it. This doesn't seem like a long time, but if you're doing it over and over again, changing thousands of things, it adds up. And in Lua, to change something similar variable, it would take around 1 second. And this increased development time tenfold. It was so much easier to make changes. But to talk to you a little bit more about the Bezier curve system, which is a huge part of the scripts, I'm going to bring up Adam Schellenbach.